million on 2 projects here. All these pumps all take power. That power comes from what we call an MCC, a motor control center, that was older than me. So it was not reliable, it was hard to do any maintenance, we had to rip it out and replace it. Not only that, but the brains, there's an entire control center, because it's all fine-tuned timing. This has all got to work. There's valves that got to open, popping, clicking. You can hear the air. When you don't hear anything, it's actually very creepy to walk this filtration plant, because I'm used to hearing the hum and the buzz of it going, and when it was off, it was I was very nervous. So we had to replace all that because it's antiquated. We can't get replacement parts. You can't work on it. You know, new electrical safety guidelines come out. You can't work on something that we call hot or live active. You can with certain training for like 50 volts or below, but you know, 120, these pumps are not running on 120 volts. That's 480. So how do we make it safe so our guys can even work on it, right? This is very Star Trek-like looking. This is the old OCC, operator control console. This was the brains of what was controlling all of those things. Half the things weren't lighting up anymore because we didn't even need them. Again, older than me. It served its purpose. It needed to be replaced. So this entire thing here took up the whole center of this room. It was so ugly. This here is what it's replaced with. Condensed down to that one piece of equipment, probably a little bit wider than this table here, and it's all there. And all the brains got moved into another room as well. There's probably 500 plus points. The wires, it looked like this cabinet just vomited wires. It was everywhere. It was such a mess. It was all summer. All summer it took us to do this. 2.2 million between this and the motor control center being replaced. And now it's back up and running. Those are the kinds of things that we get involved in. And as a project manager now, it's working with that contractor, tracking them down to pay things out or make sure that we get what the client wants. We didn't plan on replacing as many wires as we did, conductors if you will. Ended up having to replace a lot more. All those things take a lot of effort, a lot of coordination. It takes someone that can talk the talk. So being able to talk to the water sciences team, know what they need, know what the project end client really wants, and then being able to talk that talk with the contractors, you end up being almost like an interpreter. That's what happens after you work with these groups over and over again. Animal kingdom, very different. We can use chlorine on terrestrial systems, can't really use that on fish because, you know, they're breathing that in and all, and it's just a whole nightmare. But so these are some of the other exhibits that you get involved in. These are all Kilimanjaro Safari, so you've got a hippo underwater viewing, elephants, and this is a gorilla here, this guy. Big difference between hippos and elephants. You wouldn't think, oh, it's kind of the same. No, it's not, because hippos defecate in the water. And now I got to deal with that. Yeah. So, yeah, and they're hippos. They're hippos, right? Okay. So we actually do use ozone on this one because it's worth it. But you can't get it all over the park though. It's got to be concentrated. So here, if you will, this is a 3D version of the equipment pad serving four so systems. The hippo underwater viewing has these 4 filters. Now they're horizontal. You can see that this design we're doing here is for vertical. At the end, you can ask me questions that you guys please don't answer. But if you're curious as to why we went from horizontal to vertical, there was a method to the madness. But someone, you know, Animal Kingdom opened 98. They all have life cycles. All this equipment's got life cycles. Another thing for animal buildings, this is the doors, you know, it takes a lot of hydraulics and things to run these systems. So, I didn't know what an engineer did when I was a kid. I'm just trying to be here to give you some ideas as to what an engineer does to help convey that to your students. I find that to be the most beneficial thing. I'm not a teacher. I don't know that I could really tell you how to do your job better. You know, that's not what I'm here for. I'm here to answer questions to help give you ideas, to spark those ideas in your kids, and hopefully go from there, because that's what gets people excited about this stuff.
Question for everyone. What Betty was saying about the getting jobs, and I think you were talking about as a radiation therapist. Were you also talking about radiologic technologists there, or and then everyone? How are jobs in your fields for like incoming students?
The radiation therapy is, like I said, more of a niche market because it is a smaller field. But radiologic technology can also ebb and flow as far as the number of people that are needed. There are more careers available because of all of the opportunities that are in the marketplace. Hospitals, freestanding clinics. Now, everywhere you turn, there's a pediatric care center around the corner, you notice, and a lot of central cares and those types of facilities around, so those all will employ radiologic technologists as well.
My company, Disney, we have a professional internship program. It's for sophomores in college and above. I think a year after graduation, you're applicable for it. It has a minimum GPA requirement. I believe it's a 3.0. I have interns that work for me. I run the program I used to for the MEP department, ran both the mechanical and electrical selection. I got out of it because water sciences didn't have interns, but now back in my project management role, we have another one. I have a new student, she's actually fantastic. She was doing work for me when I left. But I go through hundreds of resumes to pick these students, and if I could say one thing is experience trumps all, and that's a hard thing to get when you're applying to get experience, right? But it's Disney, and so everybody wants to do it, and so the younger they start having internships in the field with other companies, other local firms, consulting engineers. You know, we've both worked for MEP firms. I work with dozens of them in Central Florida that work on Disney projects. The sooner you get into doing those types of internships and build your experience resume, the more likely when you are applying to a bigger firm or company such as Disney, you're going to jump out to me as the hiring person, you know, for those professional internship roles. That's what I would say trumps all.
I'm the curriculum chair for Burnett School, and we face this question all the time because we have 3,000 undergraduates, and what keeps me awake at night and for many years, why I ended up in sort of an administrative type of role, is I'm not concerned about the students that have the high grades that get in medical school, that go to professional school, that go to dental school. We know we do pretty well there. The rest, we talk about going to graduate school, you know, in terms of a little bit, maybe didn't quite make it to medical school, things like that. What keeps me awake at night are the ones that have the GPA less than 3.0 and don't have experience. Okay, so frankly, this is the kind of thing that we talk about. Chuck Riley's the Associate Dean in Engineering. He talks about it too. So that's the flip side of what we worry about with our graduates at UCF, and it's a concern across campus, it's a concern for the administration. We're doing the best we can. In biomedical science, it is about both internship and research. So our students are always striving to find opportunities to do research, whether it's downtown with one of the hospitals, whether it's with one of the faculty. And so if you have that experience, and I tell even freshmen, I say, okay, you may not have enough knowledge to do bench research in my lab as a freshman because you can't speak the language, but you can go shadow a physician. You know, you're just shadowing. Grunt work to do when you learn. So the sooner that students can at the undergraduate level get experience, it's not easy, but as soon as you can, and then worry about your grades. Those are the two things that get you in the door most places. And that's sort of that's the key.
business schools, they went to, New York for internship, they weren't paid. These STEM careers, they're very valuable. Instead of a summer job at Publix or something along those lines, paid internships in STEM fields, I have not heard of, now, I haven't been in a while, but I haven't heard of a non-paid, like STEM gear type of internship versus something like business where there's just so many more people vying for an unpaid internship. I would push the experience, they're paid summer jobs, high school students, and then going into college. Everybody wants to make money to go out and party, but where do you get that money from? Those paid internships is a much more valuable use of their summer.
And it's really experience, even at the high school level, if you can get into doing something that shows going that extra mile, like the initiative concept of it, they're always going to be ranked a little bit higher than somebody else. And she's right. When I was courted for jobs out of college, I was flown places, put up in hotels, treated very nicely. STEM is beautiful in that concept that, we get wined and dined for jobs. It's not, it's a different concept from, some of the other friends that I had in college who were buying plane tickets to go to interviews or unpaid internships because we're making them at it. But even at OUC, we have several OUC students that are interns that are paid pretty well. And they're, and they're off hours, it's flexible, it's very convenient for them. So it's a good opportunity.
Summer working at a hardware store, I would value from an engineer. No, I'm not trying to knock Publix, but a hardware store geared towards something where someone can learn tools, learn something of the trade, and then maybe work up if they're not 3.0 or above. Like try anything, a machine shop, how to use, and anything. Yeah, work construction. Learn how a roofer lays a roof. You'll appreciate the design elements that should go into it to improve those types of capabilities, for sure.
You're a better engineer, yes.
Yes.
I'm wondering, OUC, Disney possibly too, do y'all have curricula for high school teachers to use with their students? Some companies do, and I've used back when I taught integrated, I teach AP chemistry and honors chemistry now. But they were like, seems like the Florida Department of Energy used to have all kinds of lesson plans to help you apply what you're teaching to the real world.
I don't know specifically for UC. I could find out for you. I'd be more than happy to develop some stuff for you. I was actually going to ask you guys about that today. There's a lot of things in the design side, mathematics and things like that can definitely be worked on. So I'm going to leave a stack of business cards if you have curiosity of that. If it's for chemistry, we do have water facilities. I can try to find some people that might be able to help with that as well.
I don't know of any at Disney, to be honest. Most of our involvement, from my understanding and involvement, has been from college age and on. So in terms of gearing your students up for that, I probably would be able to speak better towards that.
My question kind of relates to that. I am teaching an intro to engineering course. I have a chemical engineering kind of background and trying to relate that to my students. Like you said, a lot of students don't know what an engineer does. And so my thought process, my dream for this course is in the spring after we get through our base curriculum is to get like field trips or guest lecture series to get engineers from all different jobs, all different fields to speak to the students or for them to visit some area to really see that real world application. That would you or company-wise or know someone that could work that out?
Again, I'm not in that circuit with Disney, but I belong to a professional organization. It's an acronym. It's called ASHRAE, American Society of Heating, Refrigeration, and Air Conditioning Engineers. They do tours and that I've actually went on myself. Things such as the ice exhibit at Gaylord Palms, for for a refrigeration tour. There's an ice bar, which might not be appropriate. SeaWorld has the penguin exhibit that's newly opened in terms of doing tours. I've gotten one for, where did the Magic play? The arena. That they've done tours in terms of how do they turn over from a basketball court to an ice hockey rink, and I've walked into these massive air handlers up there on the top floors, and so I know that there's facilities that are open to those types of ideas for at least professional organizations. If there's contacts, I can get you that for that professional organization that I have attended them through, and then hopefully that, I would imagine, be an opportunity even for field trips like what, for Applied, like you're speaking to. I enjoy them, and I'm, not in high school, so.
I know you see we don't do tours of the power plant with kids for the most part. You could imagine why. But we could definitely, come and talk to you, bring you something, show you something. I would also talk to the engineering professors here at the university. They could probably get some of their grad students to maybe come out and demonstrate some technology. Because I know that there's you guys have the robotics, they do the limbs and stuff like that. That's a really cool project. I actually know one of the students that's working on that. And they might be willing to come out and show. Because you don't get much more hands-on and visually stimulating than that kind of concept of they're 3D printing things for people with limb issues. So that would be a good opportunity as well. But
covering the landfills with solar panels is a very good idea. But are there any plans for all projects to actually use the methane of the landfill?
I'm sorry, I missed the last half of that.
Are there any plans or projects to actually use the methane that is coming out of the landfills?
Use
The
the
gas.
methane.
Oh, we actually
Yeah,
already use the methane coming out of it. So our landfill doesn't emit methane. It's not organic, there's nothing to be biodigested. But the facility that we generate power for a lot of things, it does have a landfill, an organic landfill right next to it, for waste product from Orange County people. And we actually collect the methane from that, and we burn it in two ways. One is we have a gas turbine that we burn it in, and then the other way is we actually direct burn it with the coal to make it a more efficient and clean process. So we actually do that a lot, and we're rolling out a facility down in Hollow Lot, that landfill as well. So rather than just burning the gas off of the landfill, we're using it to create power. So we're on it, as it were.
I actually have a question for all of you, for each one of you to answer. What has been the biggest surprise for you during your career that you wish you had been informed of? You're like, wow, I really wish that I had known that. Do you think that would have helped you or possibly steered you down an easier path?
Before I started the program, it had been a number of years since I had been in school, so I actually went back and started all over again with a remedial mathematics class, and I think that preparing back to the most basic systems and preparing yourself before you go into something further is very important. Very important. So teaching the basics and having a mental concept of the basics is most important in my mind.
I would have to say that for me, in engineering specifically, there's a lot of really interesting things you can Yeah, go ahead. I got nothing.
I would say it would have been nice. I know that when you're in high school, classes are more separated, oh, I'm in chemistry this year, and oh, I'm taking algebra too. Or it would have been nice to have a realization of how interconnected all those were going to be. Like I said, I dealt with a lot of chemistry and a lot of biology in the water sciences field with the animals. I wish I had paid more attention in my electrical engineering class in college because I hated it, and yet I replaced NC how to talk that talk. So I feel like that is applicable for sciences and math subjects, that they really are interrelated, even though when we're in school, they try to separate them very hard and definitively. If you struggle in geometry, but you're really good in algebra, for some reason, like my little sister, you're going to need to know geometry, and to not just pass that off because you got a C and you got through it and you're moving on. Like, it's important, probably along the lines of knowing the basics, but in terms of the interrelation of all those from the math and the science side.
Okay. I never saw an advisor, ever. And I can think of at least one specific, any advising, and now that I'm involved in some projects where advising is one of the keys, and I was able to make it through, and I know students do it today because we don't require advising, speaking out of turn, I think first year. But I was winging it the whole time. It's like an accidental career, I swear. And specifically, I didn't even understand the intricacies of applying to graduate school. I visited some former roommates at UF to watch a basketball game. I went to see my old professor. He told me to apply to graduate school. He gave me the form. I turned it in, and a month later, I got a fellowship. That's how I went to graduate school. I didn't apply anywhere else. I mean, that's how little advice I got. So when undergraduates come to me and say, what am I going to do? I spend a ton of time and I say, number one, don't do what I did, which was wing it. And two, very carefully look at all the programs, look at what you want to do, go see career services, in other words, use all the resources you have. I've been very happy, but it could have gone really bad. I think it was very lucky. So advising at every level, high school, undergraduate, graduate, whatever, and career services, there's so many services, and I think a lot of people are just like me. They just wing it. They don't go see anybody. They don't get the advice they should get to make sound decisions. They might still do the same thing if they were going to wing it, but, it's better to at least have more information.
I think mine would be getting out there a little more into the experience of the university, kind of getting out into the university, looking for different opportunities and experiencing. So what we talked about, kind of the shadowing and things like that, at the university level, there's so many opportunities across campus, not just on the advising, but also in the what other programs have to offer you. Get out there, take some classes that are outside your comfort zone, experience something different, and just kind of see what's there, because there's a lot of opportunities that you would never think that you're, at Florida State University, there was an Antarctic facility that was taking core samples from the Arctic North. I walked by it.
Right by the off-grid.
It's right by the off-grid house. It is. This man knows what he's talking
We could have
about.
blown it up.
It was underground, so it was important, but we could have tried. No, but there are things that you walk by every day, you don't know, so talk to people, ask questions, get out there and network a little bit. It's not just good in our lives now, it's good at the university level to see what's happening in your university. I mean, there were a lot of opportunities that I never saw because, I was taking my classes, I was doing my thing.
Any more questions? All right. Oh, here.
I wanted to know more about the teacher program that you're kind of putting together or putting out to NIH.
So the SEPA program is a program that's been run for a number of years, Science Education Partnership. I talked to the program officer who runs that before I applied for this program. And it's really a focused program where we chose to have Orange County and UCF as partners. We could have chosen instead to say we want to reach out to Seminole County, Orange County, English County, a bunch of partners, and then recruit teachers. There are many different ways that existing funded NIH SEPA programs run. We kind of looked at who's doing them and what they're doing, and we decided that Valencia and UCF are partners for a lot of things. So Orange County and Valencia are obviously working together. So it made sense to at least tackle it that way first. It's the long and short of it is we'll bring teachers to campus for, I believe it was 2 weeks. I've written so many of these proposals this summer, so I'm pretty sure it's 2 weeks. There are, I believe it was 7 faculty, including me, that will, I wouldn't say lecture on their subject matter, but Orange County Public Schools identified in talks with faculty here, areas of concern from the end of course exam. So frankly, essentially looking across Orange County, end of course biology exam, biology which is required, and of course that one's probably not going away. Obviously a lot of them will, and I think everybody's happy about that. That one's probably not going away. Areas of concern that were reasonably consistent. There's ups and downs all over the place. So we took that set of concepts and we tried to map them best to our faculty. Because if we're not an expert in an area, we're not going to say we're going to help you, right? So we tried to match up the faculty that we knew would be involved and the concepts that were concerned. But the program, the way we wrote it is, this is our initial plan, and it can morph over time based on changes in student success, and it's all geared toward better student success. So that's a big picture, and there's sort of this decision-making process every year as to what the concepts are that the teachers will engage with. But more importantly, here's the sort of example, is I teach metabolism. I teach bioenergetics, okay? And however bioenergetics applies to the biology course in that area, I will sit down with those teachers and literally say, this is how I see bioenergetics, and this is how I teach it in my senior level course, and these are some of the examples that I give to try to make it realistic. Because that's the hardest part, is to look at a molecule and to describe a molecule, which is very difficult to put your hands on, and to get it ingrained into a student's mind. So what we tried to do is to get the 5 to 7 best people that we knew were really good storytellers that could give their insight, hopefully, and hopefully this helps, to the teachers across the board over the primary. That's really the hard thing. And Matt Marino is going to check on us because he's an education faculty. We're all just scientists. We're not always good teachers. But you know, so that would be the education aspect. He's actually bringing all the online resources. So he's an expert in developing online resources. And of course, any of the processes that we find are beneficial, sort of best practices from every year, we're going to spread throughout the county. And, right. And in fact, every teacher will also be responsible with developing a laboratory, basically a lab, that's going to be new and different on a concept that they find difficulty with, that's developed with a faculty member at UCF. There's also some research that goes on. They can be placed in a research lab to learn completely outside of their concept, AV related. And so then we're going to find the best practices from those labs. If they work really well, spread it across the whole county. And so between every year getting a new cohort of teachers in, and over the 5, 10, hopefully 15 years that we get funded for this. Actually, our long-term goal we said was to do Orange County first. We'll get through most of the teachers if we're lucky enough to get it, and then we'll start spreading out to the rest of Central Florida. That's sort of in a nutshell.
Well, UF has a program like that, so
Yeah.
I do that every year. But I've been really wanting to get into biotechnology, but I took my sciences in the 80s, and the lab techniques and everything are so different. So, you know, if we want to teach these, guess what? All we can really do is, if we can't get into a lab and watch somebody,
Right.
is to go do these virtual labs, you know, and hope that we can actually excite students about it. But the fact is, the experience that I had in my lab when I was doing research is nothing like what they're going to have in labs. So I'm looking for something, you know, to more current, I guess,
Yeah, absolutely.
education for myself,
Right.
so that I can say to the kid, no, you're not just going to sit there and measure stuff. You know, that this is the new equipment that you're using, and this is what you're looking at. And I really don't have the experience to do that.
And that's very, so one of the things that we struggled with was, we could bring teachers to our laboratories, which are, you know, up to date, and we could teach them all these cool ways to do experiments. But if they can't afford to buy that equipment,
Right.
that's a big problem. So, you know, and a lot of places do that. I don't know if UF does it or not.
We get to borrow their stuff.
We get to borrow it, yeah.
Equipment lockers.
So I talked to the lady that runs that SEPA like a month before I submitted mine, and I said, hey, can you help me out? She said, oh, I'm submitting this year too.
Or is that Huda?
So,
Huda?
no, it's actually maybe a different one. She's out of medical school. But yes, so the question of what we want to do is to have these labs be something that everybody could do, but something that's hands-on. See, that was my goal, is find some way to talk about a concept and to do something physically with the students so that they can difficulty with, and then if it works and they see a lot of, student success from that, then replicate that through the county. Sometimes it won't work, well, it's not good, we'll try it differently. But I appreciate your issue, and the way that the teachers are going to be identified and prioritized is based on an essay. Why do you want to do this, and why will it impact your students? That's really how we're going to do this application-based process. Hopefully we get it. It's a kind of a long shot when we do it the first time.
Do you know when you're going to send that out?
It's already, that was in a while ago. Actually, we'll find out about it on Tuesday, for sure.
And then who you going to contact, Orange County?
Yeah.
Oh, yeah, I'm just kidding.
There's co-investigators. I'll leave my card.
Okay.
I'll tell you who's going to know there first.
All right, yes, I want to swim by a say there.
Any other questions?
What do you guys think, so this is just a general question, what do you guys think is missing from STEM education?
I think what you said about getting it to work together. Like when I was a teacher and I talked to teachers and stuff like that, after doing some teaching, because you don't do it, you don't understand it to a certain extent. Granted, 1 year is not enough, but to me, my ideal scenario would be a problem for a year that could be researched in science classes, could be written about in English classes, could be worked on a website, technology classes. And and down the line, math classes would work in the math for it, and you would solve this problem across curriculum. And it would really hammer home the concept of why we do what we do. Why are you doing this? What's the benefit of it? And really having that kind of concept that in English you can do research papers, you can write, dissertations on things, you can do all these things. There's a place for each education branch in that problem. And then how do you develop that? Because every group is doing their own thing. You don't really see, as somebody who's good at math and science, I didn't care about English and history. It was stupid. I didn't want anything to do with it. Sorry for English. Sorry. But in my career now, where I have to write proposals and I have to do these things, it is important. And I wish that I had better skills at it. Thank God for sculpture. But that kind of a concept where people who are good at literature and things like that can see the benefits of science and engineering. People that are good at science and engineering can see the benefits of why we'll need this in the future. I think that's, I'm sorry, don't want to take away from the other.
That's perfect. That's absolutely true. I was the same way. And now I have to convince people to give me $2 million. So if I was more actively reading in high school, then I could write their proposals. So I have to rely on other people that can write better and read it and tell me that. So I got those people.
Well, like right now, for honors biology, there's 108 or 107 standards. The majority of those standards come from math and language. So they've been integrated. And teachers learn our own choice. We teach, according to the standards, and the county pretty much says, this is what you're going to do, and we want you to do it in this order. And unless you've got a really good reason, like I did some research in Gainesville and had to create an action proposal. So I'm doing research in my classroom using my students, so I get to switch it. But the other biology teachers don't. They have to follow the sequence. But they are including a lot more integration. But in private schools, they do that where they work on a project all year long. Or they work from middle school up, so it's more of a vertical one, which is pretty cool.
I've seen through some of the new education standards and stuff, some of this changing. Common Core math, for instance, if anybody here hates it, I'll have a long conversation with you about how that's how I learned. And I'm really good at math. I aced my MCAT, or whatever the master's research thing is. I got a perfect score on it, the GRE. What's GRE? Okay, good. GRE. I got a perfect score on the math side. And I do my math that way. So learning in different ways is very beneficial to the concept. And some of the changes seem to have been heading in a more distributed concept, but I think that we need to go further and teach
students also messed up because now that's where our school system is that you take chemistry one year and then biology the next year. You take it at levels, you don't take them at the same time.
Well, then they change it.
But you can pick a problem, right?
Yeah,
Pick a
no,
problem
yeah,
that would apply to whatever that student's doing that year, right? And I don't think it necessarily has to be,
But then all your students are taking different things, like they're not all in the same math class. I have some who are going to be higher
That's
math and some who are lower.
and that's a concern, and that's something that,
Yeah.
and one of the things that we, sorry. You know, and there's different levels that you can operate on in those regards. So not every student has to be doing the exact same concept within that problem. When I was in elementary school, I was in the gifted program in Melbourne. I was born. But every year we built sailboats, and the little kids painted the sailboats and drew pictures of the sailboats, and the slightly older kids hammered nails and did this and did that. And the older kids calculated physics equations and all of this stuff. Every year we built the same sailboats, but every education level did a different thing on that sailboat in that different concept. And so the problems can be structured in such a way that, you know what I mean? Like, it takes a lot. It's going to be very creative, very conceptual, but there are definitely going to be problems